on a most sought-after topic, IGCC, towards zero-emission power plants by Dr. Dobrin D. Toporov, and the head of the Process Simulation Group at the Gas Technology Division of Tyson Group, Uday GmbH, Germany. And Dr. Toporov has a doctorate in numerical modeling of turbulent combustion and a habituation in oxy-coal combustion technology at the IWH Aachen University, Germany. In 2010, he joined Uday and is currently the deputy head of the Gasification Department and the head of the Process Simulation Group at the Gas Technologies Division, Tyson Group. Dr. Toporov is also a private docent at the RWTH Aachen University, giving lectures on combustion and gasification in a mixture of oxygen and carbon dioxide. Kindly request you to deliver your address.
And last years I did a lot of research on oxy-coal combustion, but my patient is largely gasification, so I'm working now on gasification. And from the slides which were prepared from Mr. Francisco Garcia Pena from EcoGas, fortunately he couldn't join the conference. He cancelled his trip 2 days ago, so I had to jump very fast, and as it's about IGCC, I will do this with pleasure. In the beginning there will be a short introduction about EcoGas company. EcoGas company is a holding which has several shareholders. Among the main shareholders is utilities company like Endesa in Spain, the state of France in France, and there are some minor shareholders, and among these minor shareholders is also the company where I work in Focus. It was established in 1992, and it was Focus actually built IGCC with 335 megawatt electrical output, which is located at Puerto Llano. Puerto Llano is a small city close to Madrid, and the IGCC is located here. It's strategically very well located because IGCC is using coal from the local mine, which is high ash bituminous coal, and pet coal from the local oil refinery. The IGCC power plant has several blocks, let's say. This is the demo block, a gas turbine producing electricity about 200 megawatt, and a steam turbine producing about 135 megawatt. But let's start from the beginning. The gasification part. So first, the gasifier is using a mixture between coal and pet coke. It's about 50-50%, and they are made together and they are supplied to the gasifier. The gasifier has a high pressure boiler, low pressure boiler. Raw gas is produced. This raw gas is cooled down, goes in these boilers, and then detested from the particulates. Then it goes through water fresh, the scrubbing, venturi scrubbing, and then the sulfur is removed, and then the cleansing gas is burnt in the gas turbine. The removed sulfur is recovered in a classical Klaus facility, and the gas turbine is driving the air separation unit, which produces the oxygen which is required for gasification. The nitrogen which remains from the air is used for drying, cold drying, and for coal feeding to the gasifier. The gasifier is end-to-end flow gasifier, pressurized 25 bars, and it was delivered from the company where I work, ThyssenKrupp. Here you can see the facility is the gasifier, the core is stored behind, then it is the milling stuff, the core preparation, gasifier, clean gas, then you have the power block here is the control room, the air separation unit is somewhere behind, and this is the parking for the guests, and this is the cooling tower. So as I said, it was designed to gasify mixture 50-50 of coal and coal. Why? Because the local coal has very high ash content, 41%, similar to some Indian coals. And just 100% gasification of this coal will be impossible in an entrant coal gasifier. So a pet coal from the other side doesn't have ash at all, but it has a lot of sulfur. So a mixture between two of them gives acceptable levels of ash and of sulfur. And with this mixture, the gross efficiency of the IGCC was 47.2%. And of course, the IGCC has also some power consumption, mainly from the air separation unit. So the net efficiency going to the grid is, electricity going to the grid is 42%. Here, some examples for the syngas composition were provided as it was designed and which was obtained. There are no big difference between. And you can see here the availability of the power plant around the years. Of course, at the beginning, it was running with the natural gas, then slowly it started burning gasifying coal, pet coal. There are some major issues in this period, 2004-2007, due to the problems with the gas turbine, problems with the gas filtration, the testing systems. But of course, as it was the demo plant, the operators they learned a lot how to operate IGCC and what can be improved. So it was very valuable know-how and very valuable expertise accumulated here. And recently, the problem with availability is not technical. It is more that the price, sometimes the price of electricity is very low, is lower than the cost of production. So it's not profitable to produce electricity with IGCC, or the green energy has an advantage to the market. So if there is overproduction of energy from wind or from solar, then IGCC has to stop, and so the green energy to go to the market. So this was the case in 2012. Concerning the emissions, if you operate the IGCC with the natural gas, so-called natural gas combined cycle, the NOx emissions are below the regulation, the allowed emissions. And if you run with coal IGCC mode, the NOx emissions are once lower than allowed, and second are lower than burning natural gas in the gas turbine. The SO2 emissions and the particulates are very small. So, operational data. The plant starts working at the beginning with gas, with natural gas, because there is no syngas available. So, first the gas turbine is put into operation. Then, when enough hot flue gases are produced and then steam, then we can move to the natural gas combined cycle. After that, when the natural gas combined cycle is stabilized, we switch on the air separation unit and we start producing oxygen. After that, once we have the oxygen, we can start the coal gasification. And when we get a stable coal gasification process, then we go 100% to IGCC mode. If you look at the total cost, so here euro per megawatt hour, and compare the NGCC mode and IGCC mode for the Spanish market for the prices of natural gas in Spain, you can see that for IGCC mode, the cost of electricity is about 2.6 cents per kilowatt hour, while if you burn natural gas, it's about 11.7. So it's much more profitable to use IGCC than natural gas. Future of IGCC technology. The gasification itself provides many possibilities in the front end and in the back end of the process. So you can use multi-fuel, you can use coal, you can use petrol, you can use biomass, you can use waste, separately or in a mixture. In the back end, you can produce general electricity as an IGCC case, but you can produce hydrogen, you can produce liquid fuels, Fischer-Tropsch or MTG, you can produce chemicals, ammonia, urea. So you have the possibility to choose your business plan. And IGCC or gasification technology provides the possibility to capture CO2. And you will see tomorrow in the more detailed presentation from Elcogas how it's done in Puerto Rico. So, production of hydrogen by co-gasification includes several main steps. The first one is, of course, to produce the syngas in normal gasification. The second step is to condition the syngas. You have to clean the syngas. So the fly ash can be removed, particular sulfur components if necessary. Step 3, shifting of water-gas reaction or water-gas reaction. So the carbon which is contained in the carbon monoxide is shifted energetically to hydrogen and to carbon dioxide. This is an exothermic reaction. You lose some energy, but then you can produce pure hydrogen and CO2 with this shift reaction. And then step 4, you separate these two gases, H2 and CO2. CO2 can be stored or used for some other purposes, and H2 can be used for ammonia production or to burn in a gas turbine. But this is actually CCS. That's